Have you ever wondered how electricity travels deep underground to your homes or offices? It's not magic. It's all about cables. And you know, cables aren't all the same. Depending on how much voltage they carry and what kind of insulation is used, they are grouped into different categories. Can you guess which cables handle the most voltage? Let's explore that right now. So, underground cables can be classified in two ways. First, by the insulating material used to cover them, and second, by the voltage level they are made to handle. But in real-world applications, the classification by voltage is the most common because it helps us understand where and how each cable is used. Let's start with low-tension cables. These are used for voltages up to 1000 volts. You'll find these in residential wiring, and they're not as complicated because the stress on them is low. Next up are high-tension cables. They go up to 11,000 volts. These are more robust and used in industrial and large commercial settings. Then we have supertension cables, which can handle voltages from 22 kilovolts to 33 kilovolts. These are used for high-powered systems. Extra high-tension cables, going from 33 kilovolts to 66 kilovolts, are used in very demanding electrical networks like substations. And if that's not enough, extra supervoltage cables go beyond 132 kilovolts. Can you imagine how thick and powerful those must be? Let me know in the comments if you've ever worked near such cables. Now, cables also differ by how many cores they have. That means how many individual conductors are inside the outer sheath. There are single core, 2 core, 3 core, 4 core, and more. For 3-phase power, you can either use 3 separate single-core cables or 1 3-core cable, depending on the voltage and load. For low-voltage systems up to 6.6 kilovolts, single-core cables are enough and simple to construct. They usually consist of a tinned copper or aluminum conductor, covered by paper insulation, a lead sheath to stop moisture, and a protective layer outside. Simple but effective. So, in most practical systems, 3-phase power is required, and cables are designed accordingly. For voltages up to 66 kilovolts, 3-core cables are preferred because they are economical and compact. But beyond that, they get bulky and heavy, so single-core cables are used instead. There are 3 main types of 3-phase cables: belted, screened, and pressure cables. Belted cables are used up to 11 kilovolts, sometimes extended to 22 kilovolts. They have paper insulation between cores and an outer lead sheath. Pretty simple and reliable, but not for high voltages, because stress builds up. Screened cables are used from 22 kilovolts to 66 kilovolts. They control leakage currents by using metallic screens like aluminum foil or woven copper belts. Pressure cables, on the other hand, are used beyond 66 kilovolts because they prevent breakdown caused by air voids using oil or gas pressure. Tell me in the comments, have you ever seen these cables or worked with them? So, solid cables are simple, but, you know, they do have their limitations. At higher voltages, the insulation might crack or form voids because of heat, and that can cause breakdowns. That's where pressure cables come into play. Oil-filled cables circulate oil under pressure to keep insulation layers compressed and avoid voids. These are used up to 230 kilovolts and help prevent electrical faults by filling gaps. Gas pressure cables are even more interesting. They use dry nitrogen gas at high pressure inside a pipe to compress insulation and eliminate air pockets. This makes the cables safer and capable of carrying more load at high voltage levels. Have you ever worked with oil-filled or gas pressure cables? Share your experience below. So now you know how cables are classified, what types are used for different voltage levels, and why oil and gas pressure cables are necessary at higher voltages. Which type of cable fascinates you the most? Comment below. If you found this video helpful, hit the like button, share it with your friends, and subscribe to the channel for more deep dives into electrical engineering. Also, don't forget to click on the join button to support us and get access to exclusive content. A huge thanks to you for watching this video till the end. Keep exploring, keep learning, and see you in the next video.